I promised to you that we'll talk about pointers, arrays, and their relationship. So let's start with that, shall we? Pointers and arrays. Here what you can see is an array, with element 0 to element 11, so 12 elements. And those are all characters, so it's a character array, and it says hello world, because what else would it say? And here I've just written the memory locations of each one of the elements of the array. Pointers and arrays are actually fairly similar in the way that their controls operate, if you will. So it is possible to use a pointer to traverse an array. You can go from the top of the array to the bottom of the array, and basically if you create a pointer, and in my example here we're going to assume a pointer with the name of ptr char, and the type of the pointer is going to be char, then you can point that pointer to the first element of the array, and then you can use that pointer to read all the elements of the array. Now how you go about doing that? Well, you want to increment the pointer. You can actually also decrement the pointer as well. It is possible to increment and decrement pointers. The pointer is incremented and decremented by one lot of whatever the size of its declared data type is. So if I wanted to do a statement such as this, so ptr++ for an integer, it will increment by 4 bytes, which is 4 memory addresses. And the reason why it would increment by 4 bytes for an integer is because 4 times 8 equals 32, so 4 bytes times 8 bits per byte equals 32 bits. And remember, an integer in my system is 4 bytes or 32 bits, because my system is a 32-bit system. And therefore this is why the pointer would increment by 4 memory addresses. If it was a character, such as in this case, in my example visually here, then it would be just 1 memory address. Why? Because a character is a byte, which is 8 bits, and 8 bits is the smallest addressable space in my system. So I can address every part of my memory byte by byte, and this is what has happened in this example here. So you can see the difference between this one and this one and this one and this one is only 1. Okay? So 1 memory address per byte. And here's the contents of that memory address, which happens to be, well, a character. So let's have a look now at how this would look in code and all the fun things we can do with the information that we have now, which is a pointer can be used in order to traverse an array. Let's have a look at what the fun things that we can do now are. Now, in order to replicate that example on my computer's memory, what I need to do is I need to create a nice little character array. So it's gonna be char, and I'm gonna name it R because, well, that's a nice name for an array. It's gonna be 12 bytes long, and it's going to have inside it hello world. So just copy it from somewhere else so as not to waste time. What you can see here, it just says hello world. Okay, so this is precisely the exact same data that you have seen on my slide. So next thing I'm going to do is I will definitely need some for loops. So what I want to do is create a variable so that these for loops can use this variable. So it's going to be integer count or something like that. And then I'm going to need a character pointer because we're going to use one. But before we use the point, or should I say, well, let's declare the pointer as well now, because why not? So declaring a pointer, and I'm going to call it arrptr, the pointer that I'm going to use for my array. So that's a descriptive enough name for this example. I highly recommend that you use better names for your examples when you're writing at least production code, and also for your private projects if you have any. So printf, what we want to do is, first of all, first I want to print it from the array reference, okay? So let's not do anything with pointers as a first point of call. Let's just give it a couple of new lines and then say printing from array reference. So I'm just going to print things. Nothing too fancy. And then I'm going to need a printf statement, so no, I'm going to need a for loop, and inside that we're going to put a printf statement. So for count equals 0, count less than 12, there's my semicolon, and then count plus plus, and that's going to be my nice for loop. So printing, what I want to do is print every single element of the array and also print their memory addresses so that we know what we're looking at basically. So printf, and then what we want to say here is first of all give it a new line so it looks nice, and then say okay, it's going to be %c because we're printing a character, and say from, and then I'm going to give it a %x 0x and this is basically going to print something in hexadecimal and give it the prefix of 0x so it looks good on my screen. That's going to be basically the memory address, okay? So very simple. What I want to do here is say arr cnt. So print the nth element of the array from 0 all the way up to 11. And I want to get exactly the same, but I also want the address where that element lives. So the address of, where is my ampersand operator? It's here. Okay, so I want the address of this element. So print the element, print the address of this element. So far, we're not doing anything particularly fancy. Yeah, I'm just going to bring this here. So hello world, it looks like this. It's all really nice. It's all nice and well here. And so this is, we have now used the for loop to print our array. So far, we haven't really done anything fancy. Okay, now what I want to do is I want to show you how to use a for loop in order to print the array using pointers instead of using array referencing. So I'm going to copy everything down here. Instead of saying array reference, I'm going to say pointer reference. And basically, instead of doing this, well, first of all, what I need to do is, you know that pointer we created in the beginning, which is a character pointer, arrptr. Let's point that pointer to the first element of the array, so the address of the first element of the array. So basically I've pointed my pointer to the first element of the array here. And what I want to do now is every time that we go around our for loop, so first of all, the first time we're going to print it here. So it's going to be the contents of the memory location arrptr, and then the second thing is going to be arrptr without the dereferencing. Okay, now the reason why I'm doing this is basically this is going to print the contents of whatever the pointer is pointing to in the first time that this loop is going to go around Then we're going to print the first one. So it's going to print hates. The second time we're going to go around, well, we haven't really changed where the pointer is pointing to. So what we want to do is increment that pointer. How do you increment a pointer? Well, I've shown you the statement before. This is going to increment the pointer every time around the loop. Okay? So this is incrementing the pointer by 1 byte. And what this part is going to do, it is actually, we're not dereferencing the pointer, we're just reading the pointer as a variable, and we're printing whatever is inside the pointer as a hexadecimal. Okay? And this is basically the memory address of whatever goes here. And if I'm right at all, this should now print exactly the same thing. And what do you know? It printed exactly the same thing. Okay? So we have now used a pointer in order to traverse an array. And we successfully did that. Now, in our attempt of using the pointer in traversing the array, what we have actually also done is we incremented the pointer using this statement here, arr ptr ++. There is another way of incrementing that. So what you could do is you could say arr ptr equals to arr ptr +1. Okay, and that's going to give you exactly the same effect. What I would recommend for you, do it the ++ way in this case. Okay, it is fairly evident, fairly obvious what the ++ way does in this case. So I'd highly recommend you do it this way. And here we are. I'll run it again. Looks really nice. Now I would like to look at the same thing, but from a different perspective. So let's try with an array of integers this time. So fairly similar to what we did in the previous example. Int r, and it's gonna have like 3 integers. And what these 3 integers are going to be: 22, 55, and 88. Those are amazingly beautiful and great numbers. And here I'm going to create my integer for count, or actually, let's leave that out for the moment. Let's say that we will not use a for loop this time, because it's not that many numbers that we want to print, it's only 3. So let's not use a for loop and do it explicitly. And then perhaps a pointer. Integer pointer arr ptr. That's going to be our nice integer pointer. So first of all, let's print using array reference. So I'm going to paste a nice printf statement here so that I don't bore you with myself writing it. So printing from array reference. And then we're going to do all of our printing from array reference. So printf again. And then \n %d, because that is going to be our R0. Okay, that's the first element of the array. And let's say it lives in whatever memory location, so from 0x %x. So the second place %x will be the address of R0. And let's go ahead and do the same thing for the other 2 statements. So for the other 2 elements of the array. So this should print all the elements of the array. Yeah. Let's go and have a look. As you can see, it indeed prints all the elements of our beautiful array. Okay, so let's have a look now at something a little bit different. Let's see what will happen if we try and print something that is beyond the end of our array. I don't recommend you do that. I'm gonna say interesting, not recommended. It's just going to read the next memory location, okay? But what I want to show you here is that it is possible for you to reference a part of the array that technically doesn't exist, because the array goes from element 0 to element 2, because it has only 3 elements. Now when we go to R3, we're effectively asking the computer to print the 4th element of the array. Now the array does not have a 4th element, okay? It simply does not have a 4th element. Now what is my computer going to print? Perhaps it is going to go to the next memory location, yeah, and try and read what is in there. Well, I think that's what's going to happen. And indeed it does. And what it found inside that next memory location, so this is the next memory location from this, what it found in there is the number 163. So yes, my computer didn't complain at all. I didn't see any alerts or anything popping up on my screen. It quite happily did that. Of course, it is not recommended for you to read beyond the end of an array. But if you wanted to do that, that's how you go about doing it. But don't do that. So what I wanted to do now is go and take my pointer arrptr and set it to the first element of the array. So the address of the address of arr0. So set my pointer to the first element of the array. And then here, what I'm going to do is get all of my printf statements, or get one of my printf statements to begin with, just to say we're reading from pointer reference this time instead of array reference. And what we want to do is take that, and instead of R0, what we want to print is whatever rptr is pointing to. So arrptr. So I'm dereferencing the pointer, and I'm going to print whatever's inside the pointer as well itself, which is going to be the memory location of the first element of the array. And then I'm going to increment the pointer arrptr++. And then I'm going to do the same thing. Print the pointer, print the pointer, yes, print the pointer, print the contents of that pointer, or the thing that the pointer is pointing to, so dereference the pointer, and then increment again, and then do that once again. So I have reached the end of the array, effectively. So that's going to reach the end of the array. Now, if I'm right, this is going to print exactly the same thing as this. Let's have a look. And as you can see, 22 from this memory location. Again, here we're getting 22 from the exact same memory location. Then we've incremented the pointer by one lot of integer. So here we incremented by one lot of integer, okay? And an integer is 4 bytes, and that's why we have incremented by 4 bytes. How does the computer know to increment by 4 bytes instead of by 1 byte, which is what happened in our previous example? Well, the computer knows that because it knows that arrptr is of type integer, and an integer takes 4 bytes. So when you increment it, it is going to increment by 4 bytes, or 4 memory locations instead of 1, because of the data type of the pointer, okay? It knows how many how many memory locations to increment by, because it knows what the data type of the pointer is. This is why it is important to have an integer pointer instead of a character pointer, for example. Okay? And then here, okay, is the next one. As you can see, 88 from this memory location here, and it's going from here as well. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples, and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside. Now if I wanted to continue and do the same silly thing as I've done here, all I would really have to do is again increment my pointer once more and then print that memory location outside the bounds of the array. So I'm just going to copy and paste these so that we're faster. Okay? And it is going to print exactly the same thing as being printed here. But of course, it doesn't. Let's try and run it again. Still getting a funny number. So in here, 163. So in here, this memory location contains this number 163. In here, this memory location contains 635, blah, 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 whatever. It's a completely different number. And I would like to find out what kind of demonic power has possessed my computer. How could this have happened? Well, first of all, this is a symptom of what could go wrong, or this is an example of what could go wrong if you read memory locations outside of the boundaries of your array and you expect to find some sort of variable in there. This is a very good example to demonstrate that for some reason that I do not understand yet, we will try and explore it further, but for some reason that I do not understand yet, my computer, between this statement and all the statements that follow it, has changed the value that exists in that point in memory. I don't know what that reason is, and I'm not supposed to want to find out. But of course I will investigate. But I don't know it, and I'm not supposed to want to find out. This is what could happen if you read outside of the boundaries of your array. My array is only 3 bytes, is only 3 elements long. So if I try and read whatever happens after those 3 elements, well, there is no guarantee of whatever memory location, whatever will be found in that memory location. And indeed, whatever will be found in that memory location could change at any point in time without telling me why it changed. Why? Because this memory location is being used from my program for any other number of different reasons which I might not understand and I might not care to know. Okay? Of course, I have done something I shouldn't have done, which is read beyond the end of my array. So let's figure out what happens when you read beyond the end of your array. Let's find out. Well, first of all, I have shown you already how to use breakpoints, but what I really want to do is I want to put breakpoints in all of these places to find out exactly at what point my code modifies the value that exists inside that place. And I don't know, well, the only reason why I want to find it is so that I can demonstrate to you how I can monitor different elements of arrays and different memory locations and how we can find out what is inside them. Normally, you would never ever want to debug something like this. There is no bug in my program. Well, the only bug is that I'm reading memory locations that I shouldn't be reading, really. No, I clicked the wrong button. I clicked run. What I really wanted to click is debug. Okay. So I've hit my first breakpoint here. And what I'm going to do now is step over, go to the next line. Okay. And in here, you can see my array is only from element 0 to element 2. And this is what exists in my memory. ARR PTR has not been assigned to anything yet, so it's just a random value. Don't care about this at the moment. What I want to do now is I want to actually monitor what this variable actually is. Okay, so want to really what's R3, and you can see it. R3 is 163. I don't know why it is 163. My computer just decided that it should be, so let it be. And you will see now that if after I run this step over this, it prints 163. Okay. Now my computer is going to run this line of code. Let's see if 163 will change. Oh yes, for some reason it changed. Why did it change? Well, I don't know, and I don't care, and you shouldn't know, and you shouldn't care either. Okay, but if you really wanted to find out when it changes at that time. Why it changes? Because the computer decided that it needs to use this part of memory for some other purpose other than what it was being used before. And really, since this part of memory has not been committed to anything, because remember, our array finishes before it, then the computer can do whatever it wants with it. So you cannot really count on variables that you have not declared, or you cannot really count on variables that have not been initialized staying the same throughout the execution of your program. Okay, and this is what we have actually now discovered in our program here. And if I was to continue the execution here, you will see actually that's changing. Yeah, so it's changing, and this is what happens. Now I have a suspicion, actually. I have a suspicion. Do you see how it incremented every time we incremented those? I have a suspicion that this is actually where the computer has decided to store that pointer. Anyway, this is going way beyond the bounds of what this particular section of the course was meant to teach you, but I really wanted to come here and show you this type of things, because it is very useful for you to be able to understand what the computer does behind the scenes. In this case, I suspect that the computer decided to use this part of memory as a pointer, but it doesn't really matter. Okay? We were never meant to look into that. You can see actually this seems like pointer has been incremented. Let's actually Let me get up my Windows calculator and go to the programmer side, and let's type this in as a decimal. So 63732. This is in hexadecimal 60FEFC, 60FEFC. As you can see, this is actually our pointer, my friends. This is actually our pointer. And it does make sense that it would be our pointer. Why? Because after the computer committed some places in the memory for putting these three elements of the array, then what it did is in the next place in memory, it just came and it went there and said, okay, let's put my pointer there. And here what we've actually watched is the pointer being incremented because we were reading that place in memory which happens to contain the pointer at this point in time. So yeah, again, going way beyond the bounds of what this section of the course was meant to teach you. However, I believe this is like an extra bonus section where you get to learn something. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples, and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside.